Hi, everybody. My name is Colin Zima. I'm the CEO of Omni Analytics, and I'm going to be talking about how to change your approach for doing analytics with AI. Um, so let's get into it. Cool. Most of the talk is really just this headline: Analytics for AI doesn't look like analytics. And what we mean by that is we are going to borrow a lot of the normal, quote unquote, normal techniques for approaching analytics. Like we need to have well modeled data, we need to understand things, naming is important. But as we're building out an environment for text to SQL or natural language, or really any of these kind of new LLM style approaches, we do need to change how we're doing things to make it work better. And I'm going to talk about some of those examples that we see in practice and kind of how you should apply them, whether you're using Omni or whether you're doing things on your own. So, at the very highest level, a lot of the kind of quote unquote normal analytics experience begins with screens like this. This is actually Omni. Um, and before you can even get started, you really need to actually kind of navigate the tool. So you need to decide which data set you're working with. You potentially need to go understand all the fields that exist and how they interact. So this is a sales data set. Um, and you end up with lots of fields that look like this, where you've got every single cut of date. Um, and really, when you're kind of looking at these problems, this is a lot of the sort of normal analytics experiences, naming these things well, mapping them together. That's all the same things that we've always done with BI. But when we approach this for analytics for AI, we can actually do these in completely different ways. So again, kind of finishing off the normal example, like we're selecting fields, we're building a big wide table, and we're sort of moving on. Um, when we start approaching these things for analytics, a few things change. So first is that we're often left with this sort of empty text box. Um, but kind of importantly, rather than kind of going through that multi-stage process of finding a data set, kind of narrowing down those pieces, and kind of progressively getting to the exact field that we want, we can actually really just express what we want to the AI. So we can go in and we can say, tell me about the opportunities that close this quarter. And um, beyond just asking our question, we can also start asking about the next thing that we can do. So help me learn how to improve based on what closed this quarter. Um, and you'll also notice a couple things that we've added here at the end that we're going to talk about, but add way too many fields and summarize. And the idea here is when we're doing something in a sort of classic BI context, we're constrained by what a human is doing. So again, going back to the sort of field picker example, we have to select out every individual field to understand an opportunity. Like I might have to go grab 25 different fields. They're going to span out wide. And to actually read that data set, I'm going to need to scroll back and forth on the screen. Um, it's just a generally unpleasant process for a human. If we go look at how an AI interprets these results, it can actually do a very different type of analysis than a human would be able to do. So when I take this, what it's going to do is first, it can generate more than one query. So it doesn't have to answer the query in exactly, or the question in exactly one query. It can actually go through and progressively do more than one thing. Um, but kind of importantly, it can actually take this very narrow query. It can bring back potentially more information than it needs, and it can actually synthesize. And this is where kind of building for AI and building for a human are very, very different. So again, it's even actually hard to screenshot because this is what the human sees getting an AI result is that we've built a table. It has pulled all of our closed opportunities. It's pulled this quarter. So we know it's pulled actually the content that we want. But behind the scenes, this table might actually be 14 screens wide. And we might have a very different type of result set. So things like text blobs and other types of result sets. And if we then look at the sort of synthesized result set, and we'll show you a few screens of this, we can look at patterns of wins, patterns of losses, kind of overall metrics. And this is all demo data set, so you don't have to read it too tightly. And we can actually kind of, again, like rather than thinking about BI as querying, we can actually think about the analytic that is following up the result set. So, kind of re-summarizing this whole section, the big thing that we are able to do is we're able to take these very narrow queries that would typically sort of present constraint to a human. Again, like we could return only so many columns and actually understand an opportunity set. Um, we can instead ask for a completely different structure of data set. So hundreds of columns, again, text blobs. So I think a great example of one of the things that has really transformed for us is we have a column that is called SDR notes, or maybe it's BDR notes. But the point is that it's several paragraphs of text about an opportunity. And when we think about that in the context of, again, the vanilla BI set, um, what we're doing is, like a paragraph of text in this table would sort of break the whole tabular data analytics perspective. But when I think about it in the context of AI and synthesis, this is just another column in, again, this like 12 screen result set that we can then synthesize and actually turn into significant sort of understanding of what these opportunities mean, why someone left, like why someone is outperforming, sort of nuance about a deal cycle or something like that. And the sort of moral of the story here is the types of fields and columns and data structures that might be good for classic analytics may look completely different from the types of data structures or fields that you need to actually do AI, natural language querying better. So, like text blobs, lots of columns, things like that. So, this is one example of like really changing the approach for doing analytics for AI. Um, the second one that is really important here is that in many ways, as data people, we're trained to avoid overfitting result sets. So, for anyone that has done data science, the kind of biggest mistake that you could make is, using your training data to predict, or using your training data and mixing it with the predictions that you actually need to perform, because in doing so, you sort of pollute the statistical quality of doing things out of the sample set. Or kind of put another way, when we're doing math, we're trying to do prediction of these variables that we don't understand really well, and then take them out of that result set and go kind of do prediction. Um, when we're modeling data for AI, we're actually really approaching things in almost completely the opposite way. So this is actually a real tangible example of how we approach things internally, where uh, every single session that a user participates in, we can actually understand the queries that they're issuing. So all of our customers can understand what their users, whether those are internal or external, are actually doing to ask questions. And there's two pretty magical unlocks about this. The first one is that users actually express the things that they are trying to do. So speaking as a person who was a data person for a long time before starting to build BI tools, one of the hardest things to actually understand is what your users are actually trying to do. Obviously, you're going to go build dashboards. You're going to go build content that helps them, answer specific questions. Sometimes people will actually ask you explicit questions. But on a day-to-day basis, you probably do not see 99% of what your user is actually doing. And if you do see it, you only see the results of what they were trying to do. The inversion here is that when users are entering these natural language sessions, we get very, very explicit intent of what types of data our users need, and effectively the actual questions that they are trying to answer. So, how many S1s does a sales rep have today? Like, are they in good or bad shape? Show me XYZ's pipeline. Tell me about a specific company and their opportunity record. That was the example that we just looked at. Like, what is our IRR? That's ARR for us. But there's a few different reasons this is really important. First, this tells us the data sets that we can focus on. So we can actually go look at the pockets of data. And oftentimes we'll look at this log and just understand, like, hey, this is a hard question to answer. Let me go help this person. So we can like tactically dip into the work that people are doing. The second is that because we're tying this back to this actual user experience of what users are getting out of the database, we can actually use this to tune the result sets that users receive. And so this goes back to the overfitting that we were talking about, which is we can actually look at what users were doing and we can tune the LLM and the natural language experience to make sure that we can answer that question properly. So again, back to the sort of overfitting, rather than thinking about this as like some sort of statistical process where we might overfit to a result set, if we can go in and explicitly create answers for show me the data for, show me closed won ops for the following companies, literally we can teach our environment how to answer these questions better. And progressively we can improve the quality of these result sets. So we have this really, really powerful tool to evaluate how well our environment can actually answer these questions. So this is actually a real life example that was one of the most significant improvements that we made, and I'll show you how trivial this is. So again, really simple question: what ops have we closed this quarter? So first, right off the bat, we can see it does a really good job with ops, pulling back a whole variety of columns that are interesting. It sort of can get us started on doing an analysis. But what we also notice is that it's done something subtly, I don't know, robotic, which is we asked for closed ops and it pulled literally closed ops. So close won and close lost. And for people that are in B2B, generally when we say, what business have we closed? We're talking about wins. And this is one of those subtleties where we have to sort of disambiguate things that are in the database and how humans talk. So in our data set, we actually have a column called is closed. It's pretty simple. It's just whether the op is open or closed. And we use this to understand pipeline and sort of, business metrics. Um, when a user is talking and they say closed, they don't mean that. They mean closed, but they also mean won. And this is where we can go do that explicit overfitting. So again, this is an Omni example, but this is going to apply to kind of whatever tool or whatever approach you're using. We can actually go in and add very explicit context that can make sure that we can answer this question correctly. So here we added, closed deals, and this could be a sentence, this could be text, kind of like this is where you just have to kind of play around and guess and check. But closed deals usually means closed in one. So we added a little comment that says, if someone comes in and says closed, like make sure that you do closed in one. And you can actually see a whole bunch of other examples here about how we think about things. So renewals, when we talk about renewals, what we really mean is cross-sell, expansion, and renewal, selling things to existing customers. Unfortunately, call it good or bad Salesforce hygiene, but we also have a field inside of our type that includes the word renewal. Again, like this is why analytics is hard for people that don't live in data every single day. But the nice thing is we can actually teach an LLM how to disambiguate that. Another great example here is when I say quarter, we always mean fiscal quarter in a sales context. And so rather than having the AI, sometimes guess that you mean fiscal quarter, sometimes guess that you mean calendar quarter, we can very explicitly teach it these little techniques to actually answer questions. And again, like you can see a variety of the things that we've learned over time. But the result is that now, instead of forcing our user to sort of wade through the results and, like potentially misinterpret a result set because they're looking at closed business and they don't understand that closed is open or closed, or sorry, closed or is won or lost. Now we can make sure that we're looking at essentially only wins by default. And kind of importantly, and again, like this is a little bit more omni-focused, but we can express to our user what we are actually doing. So it is very easy to peel off is one here and make this all about open pipeline or closed pipeline. It is really hard to understand that in the sort of vanilla context where we have is closed. And so again, like we have to think about tuning our results based on what our users mean from a language standpoint and pairing that back to how our data actually fits together. So like hopefully this is making it clear. There's just these small subtleties where we need to just take advantage of what AI can do differently and how to interpret language that can really improve the quality of result sets. So this is actually a real example of a customer of ours. They look at Jira tickets and, I think a lot of us have probably worked with data sets that have hundreds of dates. There's a reason, again, that this is hard for end users. And it's because there are so many different ways to interpret result sets. Like when people say closed, how do we understand what something is closed? Well, here we're looking at resolved, and resolved is based on resolve date. And so this is just one of those little micro examples where by adding the smallest piece of AI context around our Jira tickets, we can reverse engineer, making sure we can answer how many tickets we close every single week. And again, like progressively lead our users towards better result sets. And what's really nice here is we don't need to always do this in advance. We're not going to always get it right the first time. We can sort of progressively tune this to kind of increase quality progressively over time. And so the whole idea here is rather than now thinking about analytics as this sort of, I get my data perfectly set up and then users can self-serve, again, going back, the sort of classic BI environment experience, we're now thinking about it more as a feedback loop of preparing data properly up front, and then thinking about this iterative process of how to take both feedback on how to query and feedback on what queries should mean and progressively improve result sets. Um, so the outcome is that we can actually get to much richer sort of reporting and analytics use cases for end users. So here, this is like an actual result set that we got back where we can look up a customer, we can run a bunch of different cuts of their data. So we can look at, their financials, we can look at their product adoption, we can look at their support tickets. And because it can go so wide, it can actually synthesize all of that and turn it into what is literally, 6 sentences that analyze every single facet of that customer. And this is the type of sort of way to answer a question that is really difficult for a person to do, that is really easy for an AI to do. And so if you take away one thing, it's that like there's going to be a lot of places where AI doesn't really make you more productive. Like you need a data analyst to go in and do certain types of things, and you're going to do them the same way that you're doing them now. And there's another set of tasks, lookups, like overviews, a lot of these very tactical use cases where you can go really wide and really deep. But synthesis is the most important, where you can build a completely different use case for your end users. So, like, rather than thinking about it as like this replaces everything, or like this is a little like a toy or something like that. I think the people that are being most successful with AI are the people that are actually balancing what are the things that AI is great at and what are the things that, like I should be doing the way that I'm doing right now. So again, in summary, you still need a data model. You still need really good security and permissions. Like the analytics and analytics engineering jobs are not going away. What you do need to think more about now is how do my employees actually express what they're trying to do? Can I see them express what they're trying to do? And can I actually iteratively improve so that I can nail the things that they are trying to do? So it's this really simple feedback loop where rather than thinking of ourselves as sort of like a service center where things get thrown over the wall or this sort of ivory tower where we build really perfect things, we can now think in a much more looping way about how to deliver analytics and make it really valuable to the organization. Um, that's it. So if you want to learn more about how we're doing this, come visit us at omni.co. But thanks for listening.